second. So I work at Vancouver Coastal Health. Vancouver Coastal Health is quite a large health authority, although compared to New York Amirav, it's nowhere near the same size as that. You see on a sort of regular basis what our activity looks like. 10,000 births a year, 2 million home support visits. I'm not going to read everything out on the slide. Just want to give everyone a sense of the general magnitude of what we're doing at Vancouver Coastal Health, if you're not aware. I only have a few slides here because I really want to both save time for Amirav and Yanyan, but also for questions. This is a slide we continue to evolve around the diversity of our team. Our team in analytics at Vancouver Coastal Health across several sub-teams is about 160 people. And so it's quite a large team and a very diverse team. And there, as you can see here, skill sets, everything from the clinical side around those who have a nursing background, as well as to something I haven't added here that we're now exploring around cognitive linguistics. So our latest hire actually is a linguist. So everything from A to B and in between, we have a lot of different skill sets in our department that build towards creating better informed evidence-based decisions. This isn't a surprise to everyone, I'm sure. We've seen an exponential growth in data. And so there's just more and more data every day. And how we capture that and what we do with it, it's less of a problem in terms of capturing more of it at this point, and more an issue of how do we actually make sense of what we're seeing? How do we make sense of the vast amounts of data that we now have access to? Oftentimes in analytics, part of what is visible above ground, if you will, with this tree analogy, is the tip of the iceberg. Whereas about 10% of what is seen is the work that's visible. There's a massive amount of work that goes on behind the scenes in doing data quality, in extract, transform, and load, in data management, data lineage, storage, infrastructure, and architecture. And so there really is more of a conglomeration of how that comes together than perhaps there was before. And with the advent of data science and really sort of more advanced methodology in terms of how we're using our information, it really starts to stress the infrastructure as well. So one piece in terms of a takeaway really is around needing to understand the entire data ecosystem. Even as data practitioners, we might not work in all of it. Not everyone's going to be a developer, not everyone's going to be a statistician, etc. But understanding that whole overall ecosystem from when the data are captured to when it's used and when its final output is created is important, because that really influences the fit for use of the information, as well as how we can understand what we're seeing from the data. There's a tendency sometimes to overfit or to not fully understand the context, sometime in analytics, around how the data are captured in the first place. And it's a large system that we work within healthcare, and it's very easy to overlook that. One piece, and I'll speak to this at the end, is really around what trends we're seeing in healthcare that are pushing data science. And one of them is around our partnership with Indigenous health and understanding not only what you see here around chronic disease, but also in terms of experience, and understanding how to bring a decolonized data lens to how we work with our Indigenous health partners. And that is tricky, as many of you are aware. There's a lot of colonial history in terms of data capture, why data was captured demographically, and what it was used for. So how we get to that a higher place of partnership really is the onus is on us as data professionals that understand the mechanics of how data work to really bring that to the fore. This, when the slides are distributed, it'll be easier to read through. Essentially, it's a data-enabled patient journey, everything from virtual health to predictive analytics, etc. And this, my main point with showing this wasn't to go through every step that's presented here, but just to say that this is a linchpin right now in how we're working with our partners in Indigenous health, because the story that I showed here on slide 6 is a fictional one. We're working towards bringing in our Indigenous health partners and patients to really understand how we make sense of what appropriate care journey looks like from a big data, advanced analytics, and digitally enabled perspective. And so that's tricky because oftentimes it's difficult to understand for those of us that aren't in the system how all these principles work and why the system works the way that it does from a patient experience standpoint. But that is, in terms of data science and just the overall analytics or health informatics industry as a whole, a real big linchpin in terms of how we're thinking about our work moving forward from a cultural sensitivity lens. I won't go into this too much. I already spoke to it in terms of the skill set piece. The industry essentially is getting more complicated. At the same time that it's important for all of us as data practitioners to understand the full ecosystem, it's also equally important that there's a high degree of speciality that's coming to a lot of the work and how it's framed and how it's broken up. And so something that we're looking at right now in work that we're doing to revise our job descriptions and to bring them more in line with what other industries who are hiring analytics professionals do is thinking through all of the work that we have, our current portfolio of product services, where we're going, and how we align our expectations. There's been a lot of key accomplishments along the road. The pandemic, when I was reviewing the program for VADA, I noticed there's a lot of emphasis on the pandemic. Not going to go into great detail around the pandemic response that we had here at Vancouver Coastal Health. I spoke to that a little bit last year. Certainly happy to chat about that offline. But it has driven a change in terms of accelerating the importance of data in the general zeitgeist and the mindset of those that work in the healthcare industry, and I would argue the public overall. In terms of key trends, as I mentioned, diversity, equity, and inclusion, I can't emphasize enough how that's going to influence what we all do, and perhaps that's a bit of an unusual perspective. But given that I now have a role in quality, I also have a strategy team on the quality side that has a bit of a broader view on the strategy the organization is taking moving forward. This is a really big one, and it changes how we frame our work, and in the future will change how we do our work in quite a profound manner. Building on that is around patient experience, including virtual health. We see the demand and likely are going to see more demands in healthcare for patients being more participatory in care, but also to a certain extent dictating how care is delivered. And we saw that with the pandemic. There's multiple things going on there, both with patients and providers around virtual health, but definitely a very large change in and very quick adoption of a solution there. We have staffing shortages right now. This typically in the healthcare industry, we throw labor at problems. We do things manually. It's a very high touch, hands-on approach that usually involves some sort of labor, a person doing something. I think this will push us to more innovative solutions, as it's not likely that any staffing shortage is short-lived. We see this also with COVID, but many other things, that there's more real-time decision-making. And therefore, in analytics, the trends we're seeing, unstructured data, qualitative technique, why I mentioned we're looking at linguistics now around natural language processing, and I know Yanyan, you're very equipped to speak to this. Wicked problems, so problems with no specific solution where the journey and is non-deterministic problem solving. Broader skill sets therefore required. but at the same time, division of labor, rise of the what I would call the ML engineer, because in broader context, that is the hottest job right now. A machine learning engineer, someone who can create data products which data scientists use essentially. A cloud shift for modern techniques. Really, this is not just economy of scale. A lot of our vendor partners are putting the most recent tools in cloud-only solutions, and we're very heavily on-prem across pretty much all of healthcare. And then as a result, more real-time decision-making, more data more frequently. However, in terms of the workforce, this is something I go back to that I saw from a marketing professional, so outside the analytics field. And the message was the secret sauce is IQ plus EQ plus TQ plus BQ plus CQ. And IQ, I think everyone knows what intelligence quotient is. And then emotional intelligence being EQ. T is technology quotient, and BQ is bloody quick. So we definitely have seen this more recently, more real-time decision-making, more demands on adding a high degree of insight really quickly, not just a snap, reflexive, anecdotal-based decision or judgment, but really in-depth, insightful decision-making, but as fast as possible. And then CQ is creative quotient. And so at the end of the day, and I'll end, I have one last thought after this, but in terms of careers in data science, this, despite all of what I said, the same still remains. As typically, especially for those of us that are not clinicians, a passion for better healthcare is really important. No matter how much skill set or technical knowledge, we saw this through the pandemic. It's like no amount of money, no amount of recognition can really replace that drive to want to contribute to better healthcare. And I certainly saw that in the organization, a self-filtering of individuals that really had that deep, deep passion for it versus others that perhaps didn't. This is a journey of lifelong learning. It's about work-life integration, not necessarily just work-life balance. This is a whole nother topic, but I certainly learn from a lot of other things that I do, and I don't just work. I'm not just focused on informatics and data for healthcare with everything that I do. I have very broad pursuits, and I learn from those too. And because of the broadness of the industry now, it really requires that kind of work-life integration. Not that you should be working all the time, but how do we, as individuals, contribute to the whole? How do we learn from everything we do and cross-apply principles? Critical thinking, creativity, and holistic solutions, even if sometimes this means a low-tech solution. In fact, as it comes to data science, the best solutions are the simplest solution to a problem. And oftentimes those don't require advanced analytics techniques, but the good ones are when we're using the simplest solution and it happens to be complex because the problem is complex. So we saw this most recently when we were doing classification of COVID cases between incidental and significant, and it uses a classification model and is quite an advanced piece of work relative to what we typically have done in the industry in the past. That was the simplest solution. So it's really important not to create solutions looking for problems, and healthcare is very prone to that, given our severe limitations in operations and the on-the-ground improvement work after we've done our work as data professionals. Someone on the front line has to implement it, and that usually is more the limiting step in terms of time, resources, and energy, as opposed to an advanced analysis, to be honest. The last piece I'll leave you with is the importance of community. As mentioned in my bio, I'm the chair of the Vancouver Analytics Board. I do think we can learn from other analytics in other industries, and I definitely have and continue to learn as being part of the Analytics Board. So I'll urge you to check it out and look at what we're doing. It's quite an interesting collaborative that we have there. So with that, I'll end my portion of the presentation. Thank you, everyone, for listening.
So it's wonderful to be back at VADA. It was a terrific year that I spent in the program last year when I graduated. And it's always an honor and a privilege to be invited to speak and to learn from just the immense talent that's within the VADA program. So currently, not long after I graduated from VADA, I started in my role as a digital health program manager with the Integrated University Center of Health and Social Services for West Central Montreal. And we've done quite a bit in terms of building our portfolio when it comes to the data infrastructure and our analytical capabilities. And I will kind of dive into a little bit of our story over the last year and where we're going. So healthcare delivery in Quebec is organized differently than what you may be familiar with in other provinces, as you probably heard from other speakers today. The provision of services is not under the auspices of a provincial health authority per se, like in British Columbia, or an entire provincial health system, like in Alberta. Quebec is divided into what are called integrated university or integrated centers of health and social services, CIUS or CIS in the French acronym. There are 34 overall integrated centers across Quebec that were carved out and created in 2015 that merged 320 healthcare institutions across the province under the legislative bill 10 in Quebec. 5 of the integrated university health and social service networks are found on the island of Montreal. You can think of Montreal, for those who've come to visit Montreal, that it looks like either a foot and ankle or shaped maybe like a banana. Our integrated health system, RCUS, is found right in the middle of the island and slightly west, hence West Central. It covers one of the most densely populated areas of Montreal, including one of the largest boroughs within Montreal, which is Notre-Dame-de-Grâce, NDG. For those who visited that area, it's a great little neighborhood of shops and neighborhood markets and a lot of duplexes and apartment buildings. We serve a population of 357,000 individuals in our CIUS. It's a major research engine as well, we have 5 research centers, a teaching hospital, which includes 4,000 students, and we also have 700 physicians and 9,000 employees. There are also double the amount of unique visitors who come into the CIUS to seek acute or specialty care. And of note that I want to mention is that within our territory, there's a large percentage of elderly people. So for example, in the demerged borough of Côte-Saint-Luc, which is in our territory, almost 1/3 of the population is over 65. So the 34 sites under our CIUS provide a diverse range of services. We offer acute care at our flagship hospital location, which is the Jewish General Hospital, which has one of the busiest emergency rooms, if not the busiest emergency room in the province. We have a number of long-term care and residential facilities, along with palliative care. We have palliative care, a residential center where patients can be admitted, as well as palliative home care. Other home care services we have include rehab, home oxygen support, daily living facilitation and support as well, which are all under part of our umbrella in the CIUS that we provide. We have dedicated rehab facilities as well for both short-term and intermediate recovery and support. And the CLSC, or Service Center, that provides laboratory services, vaccinations, and limited amount of family medicine visits. There's also birthing centers under our CIUS auspices, and can therefore think of our integrated services as birth to death for our population. The reorganization into a CIUS structure helps push healthcare delivery from sites to service, makes it more transversal. It also starts to shift our thinking to population-based care, value-driven care, and trying to achieve our digital health vision, or our CEO's digital health vision as well, of providing care where the patient is located, is at. So the move to this idea of population-based care and value-driven outcomes that involves more a push out to residents than a pull into the system per se, is trying to integrate various services of data into understanding the users that we serve. This approach requires a broader vision of building an integrated data approach that can then have data science components layered on top of it when strategizing roles and building out an analytics ecosystem. Our traditional collection of data over here, over on the left side, perhaps covers 10% of the total influence on health outcomes, while the remaining components we're starting to collect and need to collect as well help make up the remaining 90%. So the idea of what lifestyle and behavior data are we starting to integrate, genetic information that we can incorporate into our databases, into our data ecosystem, and then environmental, socioeconomic conditions, and even trying to identify where there are certain hotspots or where certain areas patients may need more assistance. So the ideal flow is to build an environment that can move all the data we collect and store into information, and then take that information and translate it into knowledge. So the data engineers and analysts we are hiring are to build the ecosystem that consistently allows high quality data to be extracted into easily understood visuals and trends, and to define, standardize the key performance or metrics of care provision and delivery, and the population profiles that move into the realm of practical insight and operational use. The flow of knowledge can help address potential bottlenecks in the system from a process engineering perspective. So that's why we kind of take this approach. It provides proactive discharge planning as well, and can address chronic disease in the community as examples. We already are operationalized some of this flow of data to information into knowledge by having a real-time command center that helps alleviate pressure on the ED or transfers between our facilities. So what data architecture will we need to help accomplish this ideal that I just showed in the previous chart? And that is by looking at what kind of our model or architecture is of the future. And we're starting to fill roles to help achieve this vision. We're really finding different data roles that can help be experts in a lot of different components of this architecture. So a modernized EMR is really at the, or electronic medical record is at the heart of this. Frankly, in Quebec, we are behind in having a modern and singular EMR across our enterprise, across all our facilities, to have the full documentation capabilities. We have to certainly make some quantum leaps, some major advancements in the EMR space in Quebec. And we will. I think that's certainly the future. Quebec will be taking some of those quantum leaps and joining what other provinces have done or are starting to do. So we'll see a lot of development in that space over the next 3 to 5 years and beyond. We will also need data engineers to create a unified pipeline of data into the clinical data repository over here using HL7 FHIR standards, and build a comprehensive data warehouse. We're also in the process of integrating a synthetic data engine into our data ecosystem, our data environment. Synthetic data use is another area that's going to see a lot of growth, I believe, over the next few years. It's already a frontier that's integrated into the data ecosystem of a lot of healthcare organizations. I know they use a similar synthetic data engine that we're looking at in Ottawa, as well as Barnes Jewish in St. Louis in the United States. So the roles and growth in our data analytics sphere is going to incorporate the integration and use cases from this synthetic data. And it'll also help speed up exploratory analysis while maintaining patient privacy and security. The synthetic data engine will also help investigate research questions without a need for full ethics board review in some instances, and allow things to get into operations or practice perhaps a bit faster. We will continue to have traditional dashboard reporting. So we have quite a bit of a number of roles that are focused in that space. We use Power BI as our tool. We will also continue to enhance our data science and artificial intelligence capabilities in the overall data environment. You can think of, if you look at this model, of a dotted line from our synthetic data engine to data science, as the predictive modeling, machine learning that pulls from that engine will directly be incorporated to operational planning. And of course, all this entire architecture requires key supporting tools for success, which makes up our portfolio of roles and skills that we're certainly looking for in our potential employees. And that includes things like data catalog, extract, transfer, load, or ETL procedures, and our messaging queue. So we structure our roles taking into account the larger data ecosystem and infrastructure. So that again starts with the data catalog and having the metadata layer that is foundational to executing any data strategy, and then building up our required components from there. So a glossary of all the terminology like data dictionaries, having rules and processes outlined, including how data is governed, doing a lot of work on data governance right now throughout our CUs. We're also doing a lot of work in defining what our key objectives and metrics are going to be as we move up this pyramid from the definition of our data into our standardized metrics. And ultimately, we want to know what our goals are for providing better care for both the patients and population that we serve. And this echoes a lot of Michael's point of 90% of what you see is under the surface. So we're really focused on creating and hiring data roles that provide all the infrastructure, all the pipelines, all the standardization and the dictionaries that really are necessary in order to have quality data, in order to be able to do analytics properly. So our strategy in growing data engineering and data science roles is to accelerate the data maturity within the organization. It really involves a comprehensive approach to how data is handled throughout the CUs. It requires a process of building a data access and control function, promoting and enhancing data literacy, especially as self-service tools may start to be rolled out more often, ensuring data quality and review, data storage and timely extraction, and of course, a governance process. Our roles are there to support this maturity, and the need is there to move the organization forward that addresses the entire data ecosystem. All the foundational elements and components to ensure data quality, timeliness, and comprehensiveness are absolutely critical to having an analytical environment that asks the right questions and operationalizes the right initiatives. And data literacy is another area I see with quite a large amount of growth over the next few years, as a lot of machine learning is going to be incorporated into the data environment. There's going to be a lot of self-serve, but not everyone is data literate or can explain all the nuances in the data or in trends, or even in predictive modeling, which the VADA program graduates are very adept at teaching about various analytical techniques and analytical findings. And that's going to be important to many different audiences throughout the healthcare organization, especially as predictive models like readmission risk, perhaps length of stay risk, perhaps medication adherence risk, things of that nature are going to be more incorporated into some of our tools. It'll require some education to explain what they mean and how they should be handled, as well as any caveats or limitations to them. So overall, I would say our analytics strategy and the individuals we hire are aimed at moving us up the HIMSS adoption model, which I know many of you have seen, that reflects what analytical maturity should look like within an organization. We constantly evaluate what stage we are at in the HIMSS model, and we're building the engineering and data science components that can get to the personalized and prescriptive level, stage 7. That's the ultimate goal. It's all done methodically and mindfully with our technical skills that are needed, statistical skills, and collaborative skills. And finally, last but not least, I do want to talk a little bit about the components needed to fill the data engineering and data science space, as depicted on this Venn diagram. So there's a strong overlap when it comes to working with big data, analysis, and programming skills. They both, at least in my opinion, have a role to play when it comes to advancing data literacy throughout the organization and enhancing how people understand and interpret data. We are growing data engineering quite a bit in our organization to support the architecture, which I talked about earlier, as well as our infrastructure. And there are lots of opportunities right now in our CUs in Montreal for those technical roles. We are hiring at a little bit of a frenzy at the moment and filling out a lot of these technical roles to build our underlying architecture for data capability. There will also be a need for the data science space as well to really identify innovative use cases for better care delivery, proactive community support and operations. And that goes along with all the other familiar skills that we associate now with data science. With that, I do want to acknowledge my team at the CUs. A lot of the information that I received, a lot of the visualizations on the slides came from them, from our project manager, who's helping implement our data warehouse environment and our synthetic data engine, our data team lead, as well as our lead on kind of an internal consultant role in data science as well. I gleaned a lot of information from him as well. So it really was a team effort. I was the one presenting, but it's the team effort at the CUs that contributed a lot to this presentation.
Yeah, thank you for having me. It's an honor and privilege to speak here. It's nice to meet you all. So my presentation actually is about an example, a technical example, and then I will walk you through the technical details here, comparing to Michael and Amirav's presentation. Those are more strategy. So mine is about the technical example. So can be fun. So bear with me. Hope I won't lose any of you. So my name is Yanyan Li, and I'm going to present a use case of data science approach to find healthcare information technology errors from a patient safety incident database. So this is the agenda. I will start with the description about the project background and motivation. Then I will give you an overview of data science and its methods, then including NLP and machine learning. Thirdly, I will review the NLP and machine learning methods used in this project. Lastly, I will summarize the results and discussion future research opportunities. So in this presentation, you won't see the real data because I'm only focused on the methodology today. And then I will use some examples, sample data to show you how the technical piece works. Okay, so the first one is about the project background. So the patient safety risk and incidents caused by problems associated with the use of healthcare information technology are now recognized as a technology-induced errors. Research has shown that incidents of error increase with high uptake of technologies in healthcare. So to reduce the errors and suggest methods for intervention, we need to know what and where those errors are occurring. So an incident reporting database is a source to find and analyze those errors. So for this study, I chose a local patient safety database to analyze. So with the patient safety event database, what we can do is to analyze the incident reports to uncover error patterns. Furthermore, a systematic approach to study correlations and dependencies of variables recorded in the database will enable the discovery of error patterns and HIT improvement opportunities. So this is according to the literature review done by Shaban et al. In 2022, they identified the following currently available international patient safety event database. To be cognizant of the time, I won't review the databases in detail. And you can see the reference at the bottom of the screen here. So the project motivation, this project, because we want to uncover trends and insights, and also want to learn patient safety, technology-induced errors. So we want to look at a local patient safety database and see what we can find out. So the business context of this project is a large portion of the patient safety reports are entered as unstructured short texts. So in order to discover useful information and themes and patterns in the data, a manual exercise was conducted by 3 analysts at the beginning. And then later we asked, can we do this in a less resource intensive fashion? For example, automate the thematic analysis by using NLP and machine learning techniques. So the next slide. So now let's flip over to talk about data science, NLP, and machine learning. So the data science refers to the processes of extracting meaningful information and deriving actionable insights from large sets of structured and unstructured data. So the output of data science project is a data product, which can be an application or a tool that uses data to help improve business decisions and processes. So comparing to other interchangeably or commonly heard techniques like data mining and data mining. So the data science approach data science can actually analyze unstructured data. But data mining, you need to have a data warehouse and have those structured data to analyze with. So data science actually is a broad field of study which leverages the latest methods developed in a variety of fields, including management science, computer science, statistics, and mathematics. So the state-of-art methods include NLP, machine learning, deep learning, data mining, and text mining. So here is this is an example of the process of NLP. Let's say we have some free text data from Twitter on the left-hand side, and the NLP will convert this data into a machine-readable representation of key elements. And then this will be the input into the machine learning algorithm to further analyze. Then what are the key elements? So key elements are terms that best describe the subject of a document. For example, on the screen, for the first free text, the World Environment Day, March cash, oceans, improperly disposed land, those are the key elements that represent the most relevant information contained in the text. And then what's machine learning? So machine learning is, by the name, is a computer has been taught to recognize patterns within a data set. It includes supervised and unsupervised machine learning. Supervised machine learning uses labeled data sets as examples to train data and to classify data and predict outcomes accurately. Unsupervised machine learning allows the algorithm to learn the data, discover patterns, and cluster unlabeled data together, so which is unstructured data. So in our study, we use unsupervised learning. And then the methods applied in the project include the following. And the process starts with the extraction and grouping and cleaning of the pre-test patient safety event records. And then the basic NLP techniques applied, the features of the test data were extracted, and the dimension of data were compressed in order to do the clustering. Then unsupervised machine learning methods were applied to cluster test data. And then the models and the algorithms were tested, evaluated, and selected based on the performance. And then the models we tried, tested, and evaluated are listed on the right-hand side, and I will explain each of them in the following sections. Please note that for the first step of the unsupervised learning, we did try two methods. One is the one is the k-nearest mean, and then the other one is topic modeling, which is, and then for the topic modeling, we tried two models, which is the LSA and LDA was selected because of the performance and accuracy. So this is the graphic view of the process. Now I would like to flip to the NLP and machine learning techniques applied in the study. So the step one of the NLP process is to remove punctuation. For example, for the original test, it's a word on the top right corner. The first step is to remove the punctuation. And then after that, then we remove all the English stop words, which is did, were, are, that, of, the, in. And then after that, we do tokenization, and it's to split the text on white space and then into individual words. And then for the next step, we perform the words association. Because when it's tokenized, it doesn't make sense. So we need to reassociate it. And then also we need to to do the stemming. So for example, this post will be back to its original term, this post. And then for lemmatization, we associated the words that for morning, for example, AM in the test data, it's AM. It's actually in the clinical context, it's the morning. The clinicians use AM to represent morning, so we do the lemmatization to associate words to group. And then the steps are repeated for each free test record till a mathematical representation of informative words is identified. And then for the test feature extraction step, we analyze a group of words together instead of one word at a time, which is called, which we use the n-gram algorithm. So we associate the words together after the tokenization, it's individual words. Now we associate them into improperly disposed. We associate them back together, and then and then we play the 3 gram to see if 3 gram makes sense or 2 gram makes sense, and then determine how to group the words. And then after that, we do the term frequency and inverse document term frequency and inverse document frequency model. We apply that algorithm to understand the context of words across the entire corpus of documents. So instead of just its relative importance in a single document, so the output of the TF-IDF algorithm is a matrix that can be input into machine learning models, which is unsupervised topic modeling later. So as a recap, we have reviewed the extraction, grouping, and cleaning of the data, and then we apply the tokenization stop words removing, punctuation removing, stemming, lemmatization. And then we do the n-gram association and then the TF, NDF to extract the features of the text. And then now we are at the unsupervised machine learning, which is topic modeling. And then I'm only focused on the model we actually selected for the final model, so which is LDA. So the topic modeling, so when we have a large amount of unlabeled text data, we will not be able to apply supervised learning approach to create machine learning models for the data. As such, we can only use unsupervised machine learning, which include cluster and topic modeling. So topic modeling allows us to efficiently analyze large volume of text by discovering clusters of documents and grouping them together into topics. So it's important to know that users may not know the number of topics in the text data. We just guess or estimate, and then what those topics are to start with. So the assumption here is that the documents that are clustered together share similar topic ideas. So it's as such, it's up to the user to iteratively test and determine what those topics represent and what clusters to choose. And then, so the topic modeling technique is the one of the topic modeling technique is LDA, and which is the most popular technique. And it's based off probability distribution. It was first introduced in 2003. As previously mentioned, LDA assumes documents with similar topics use similar groups of words. As such, LDA latent topics can then be found by searching for groups of words that frequently occur together in a document across the entire corpus. For example, for the short text messages on the screen, as you can see, the first one, if we apply for all 5 of them, if we apply LDA, then the output is the bottom ones. So for example, the first message, it will identify 100% it belongs to topic 1, and then the number 2 and number 3, 100% belongs to topic 2, and then number 4 belongs to number 1 again, and then the last one actually has a mix of topics. So 60% belongs to topic 1, and then 40% belongs to topic 2. So those are the output from the LDA. And then so let's talk about this in more details. So LDA actually is all about probability distribution. So a probability distribution is a more complex way of saying a mix of different things. So on the left, every document consists of a mix of documents. Every document consists of a list of topics belongs to topic A. And another way to say this is, in the more technical terms, is every document is a probability distribution of topics. For example, the last document is a mix of distribution of the different topics. And on the right-hand side here, you will see that. So on the right-hand side here, you will see every topic. So the mix of words for that topic. Yeah, so this is the LDA. So this is another example by applying LDA on the tasks, the questions pulled from Cura. So those are this on the left hand side is a list of questions on Cura, and then on the right hand side is the output from the LDA algorithm. So taking the first one as an example, what's the step-by-step guide to invest in share market in India? So the LDA model determines it belongs to topic 5. And then on the right-hand side here, the topic 5 actually is this one, the first one, which includes the words like India, and then country, and then business. So that's why the LDA thinks this actually belongs to topic 5. So this is the LDA topic modeling. And then, so as a recap again, so after we apply the LDA, then we analyze the attributes of the topics here. And then based on the keywords here, we actually, in the project, we manually identify the themes based on the keywords here. So as you can see, those keywords there, it's actually, it's very unique to each topic. So based on that, we can interpret it and identify the themes. So the results of the performance is it took the manual process took 150 hours in total by 3 analysts, while NLP and machine learning took only 15 minutes. And then we also identified the characteristics of the database, and I won't go through in detail in this presentation. And then the opportunity is the data science pipeline produced 95% alignment, and the pipeline can be scaled to analyze safety event data in real time and provide up-to-date information for informed decision-making. And we also found out error classification system for patient safety events could form the basis for semantic annotation of the reports. More review of the patient safety events from community of HIT professional would be helpful, and more patient safety professional contributing to the instant database annotation task will help to create a data playground to apply machine learning and deep learning methods. So that's the end of the presentation. Thank you.